Hello, everyone. I'm very happy to give you a talk about the Virtual Observatory, the IVOA, Chenzhou, and FAST. First, here is a brief introduction about FAST, 500-meter aperture spherical radio telescope. In the picture, you can see the comparison among FAST and other leading radio telescopes around the world. So the FAST project is approved by the Chinese government in 2007, and we complete the construction in 2011. Early in this year, we passed the central government inspiration and stepped into the operations phase now. FAST is the largest radio telescope with the highest performance. Here is a current designed sky service and science platform for FAST. Currently, as the first normal sky survey, CRAFS means Commercial Radio Astronomy FAST Survey. This survey will look for pulsar, galaxy, and image sky surveying, and looking for the fast radio burst. For this sky survey, we hope to find about 1,000 pulsars, more than 500,000 galaxies, and observe more than 10 billion H1 images, and new discover about 50 new fast radio bursts. FAST is the largest radio telescope now, and you see from the CRAFS sky survey product, FAST will collect about 10 to 20 petabytes per year, the observation data. So it is a big data stream for radio astronomy. After the CRAFS sky survey, there will be another galactic plane and the Andromeda sky survey plan. The Chinese Virtual Observatory team is working together with FAST team, and we design and developed a wheel-driven science platform for FAST to support a strong, provide a strong support for the FAST observation. Here you can see the web portal for the FAST, from the proposal submission to data archiving, data management, and online data analyzing and processing. You can do the tasks just on your cloud. So driven by FAST and other very big scale sky survey or astronomical facilities, including the SKA, LAMOST, Rubin Observatory, TMT, and ELT, and other facilities. The astronomy research has become a big data scientific research. In the big data area, astronomers and IT experts facing various of challenges. So the idea of Virtual Observatory was initiated at about 20 years ago. We know the web is transparent. The goal of the Virtual Observatory is to achieve the same feeling of for astronomical data that is all available to explore in a single transparent way system. In Virtual Observatory platform, the astronomical data sets, tools, services should work seamlessly together. So the VO will allow astronomers to interrogate multiple data centers in a seamless and transparent way. Just like the World Wide Web, the WIO is not a fixed system, but rather a way of doing things. So WIO is a complex system. The blue verse is my definition for the virtual observatory. It is a data-intensively online astronomical research and education environment, taking advantages of advanced information technologies to achieve seamless global access to astronomical information. So simply, WIO will provide our astronomers, our users, a digital universe. In 2002, the International Virtual Observatory Alliance was created as an organization that debates and agrees the technical standards that are needed to make the WIO possible. The IVOA is also a focal point for WIO aspirations, a framework for discussing and sharing WIO ideas and technology. Currently, in the IVOA, there are 21 member projects. All the BRICS countries have WIO projects. Brazil, China, Russia, India, and South Africa. This year, Netherlands and Thailand show interest to initiate their WIO projects. And currently, the IVOA consists of 6 working groups and 8 interest groups. So the interest groups will collect the requirements from our astronomical communities, provide the requirements to the working groups. The working groups will follow the requirements to define, design protocols and standards for the interoperability of our data sets and tools. Each year, the IVOA will organize 2 interoperability meetings in May and in November. Currently, the IVOA has been developed about 46 interoperability standards to realize the dream, the blueprint of the virtual observatory. During the last decades, there are a number of interoperable applications and services developed, designed by the WIO projects all around the world. For example, there are some examples. Maybe you know Aladdin from CDS, TopCat from UK, Spectral Tools from Spanish, and the notebooks is very popular for young astronomers. At the same time, more and more science portals will embed WIO services and tools. There are some examples, you know, the ESO science portal, the Worldwide Telescope, the Firefly from Caltech, IPAC, ESA Sky, and the gravitational wave science portals, and the CDS web portal, and some other tools. So the IVOA is more and more powerful to support strong support for the astronomy research all around the world. And from the UN, from the science data community, they initiated the concept of FAIR. FAIR means refundable, accessible, interoperable, and reusable. So just from the beginning of the virtual observatory, WIO is a FAIRable platform for astronomer, for astronomical community. In the following slides, I will give you a brief introduction about the China WIO. China WIO is the national WIO project in China, initiated in 2002 by Chinese astronomical community, leading by NAOC. And we became a member of the IVOA in the same year. here you see the research and development focuses for the China VO. We first hope to design a China VO platform and to realize unified access to online astronomical resources and services for our end users. And then the China VO team will work together with products and facilities to make their products, especially big products, VO ready or VO available. And then the team will working together with astronomers, especially young astronomers, to take full advantages for VO resources and services to do better science. And then the VO resources are very valuable for education and public outreach. So the China VO designed and executed a number of EPO events and products during the last decades. And we also collaborating with Alibaba Cloud, one of the major cloud computing provider around the world. And so the China VO has the ability for a global infrastructure-based astronomical research. Last year, the China VO and the related National Astronomical Data Center was announced by Chinese government as one of the first 20 national scientific data centers. So the China VO's platform, the NADC, we hope to take the advantages of advanced IT technologies to provide a whole life cycle management platform for the astronomical research, from observational proposal submission to observing team support, data archiving, data management, data analyzing, and data release. So it will be a one-stop platform for the astronomical research. This is my last slide. So from my introduction and experience, we feel the flagship project has a prospect of becoming an indispensable global infrastructure for astronomy research, especially in the area of big data. However, for this flagship project, we need support some requirements. We have some requirements. For example, the first is cyber infrastructure. We need a better or a very good cyber infrastructure to support our projects. And one of the most important issue is international bandwidth. International bandwidth is very, very expensive. It is almost impossible supported only by astronomical fundings. So we must get the top level support from our central governments. And then the next is data storage and cloud computing. So we need to get some fundings. This funding is limited comparing to the international bandwidth, but we need the number, a big funding for data storage and cloud computing. Another important issue is research and development team for the flagship project. And then, of course, we need interdisciplinary cooperation among all the BRICS communities, not only for astronomy, but from other disciplinary, including IT, artificial intelligence, computer science, and maybe some other related fields. So this is my slides. Thank you.
Thank you very much, Chenzhou, for the very interesting talk. Any questions? Okay, thanks again. It was a pleasure to see very interesting initiatives from Chinese side. Thanks again.
Thank you.
And thanks to all speakers of the session for a perfect time, because we have a very narrow time slot convenient for different countries. So thank you, really thank you very much. And now we have a break for 15 minutes and we'll start in 15 minutes sharp.